Hello guys, welcome to Physics Grad. This is the fourth video on canonical transformations, and in this video we are going to see some different types of generating functions which are used to construct systematically canonical transformations as we have seen in our previous lecture. Alright, so let's begin. So we know that generating functions, as we saw in our previous lecture, can be used to systematically construct canonical transformations. Okay, and we had seen the following relation relating the modified Hamilton principles. From our modified Hamilton's principle, we had seen that the relationship, the following relationship was valid. So the relationship was df by dt equal to summation pi dqi minus summation pi dqi plus h dash minus h dash minus h. Okay, so this I'm going to call it as equation number 1. This relation we have derived in our previous lecture. So what does this relation tell us? It tells us that these quantities are related in such a way that they should be equal to the total time differential of a function whose variation at the initial and final positions or coordinates must be 0. Okay, which means it can be a function of only these quantities whose variation at the endpoints are always going to be 0. Okay, and we had seen in our previous lecture that if we write our f as equal to some function of f1, some function f1 of the old generalized coordinates, the new generalized coordinates and time, then and substitute this in our equation 1, then we got the relation that our dou f1 by dou qi is equal to pi, dou f1 by dou qi equal to minus pi, and our h dash was equal to h plus dou f1 by dou t. So here we were able to express pi as a function of q, and t, all the q's and t, and from this we can invert the relation to get q in terms of all the old coordinates and momenta, which is our first half of the canonical equation. From there we can get the new momenta by substituting for q in terms of q and p's, and this is anyway a function of q, and t, and from there we get the second half of the canonical equations, and we also saw how to express h dash in terms of the new transformed variables. Okay, so this much we had already seen in our previous lecture. Now this, when we express our function f as a function of the old coordinates, new coordinates and time, then the generating function resulting from this kind of a substitution to f is called a type 1 generating function. Okay, so f1 is called type 1 generating function. Okay, and it depends, or it is a function of the old coordinates, new coordinates and time. Okay, now what if we want our generating function to be a function of, so what if we want the generating function as a function of the old coordinates, the new momenta and time instead of the new coordinates. Then for this we we need to substitute for f as follows. So in equation 1, which is this relation, if we write our f as follows, if f is written as sum f2, which is a function of the old coordinates, new momenta and time, minus summation of qi pi. If we do this, then our df, which is equal to df2 minus summation dqi pi minus summation qi dpi. Okay, this must be equal to, so from here if we take this dt to the other side, so in fact this will become dq dot. So taking this to the other side, what we have is that this should be equal to summation pi dqi minus summation pi dqi plus h dash minus h dt. Okay, so now if you see these two quantities, they are equal, and I can cancel these two guys, which gives me df2 is equal to summation pi dqi plus summation qi dpi plus h dash minus h dt. So if f2 is our generating function, then we have the relation dou f2 by dou qi equal to pi, dou f2 by dou pi equal to qi, and our h dash is equal to h plus dou f2 by dou t. And here again, just like how in our previous lecture we were able to get the canonical transformation equations by writing our pi in terms of qt, in this particular case our pi is expressed as a function of the old coordinates, the new momenta and time, and from this if we invert the relation we can get the new momenta in terms of the old momenta and coordinates and time, which is one part of the canonical transformation equations. And then we have our new coordinates in terms of these three guys, and from here we already got p in terms of these guys, which we substitute in this equation, from where we can get qi in terms of the old coordinates and momenta, and that forms the other half of the canonical transformation equations. And by substituting these for our old Hamiltonian and f2, that is writing our old coordinates and momenta in terms of the new coordinates and momenta by inverting the relations, we can get our h dash in terms of the new coordinates and momenta as well. So that procedure remains the same for any generating function, and here this f2 is called as type 2 generating function, and this is a function of the old coordinates, new momenta and time. So f1 was a function of old coordinates, old momenta and time, new coordinate and time, whereas f2 is a function of old momenta, new momenta and time. Okay, now similarly if we write f as equal to f3, which is a function of old momenta, new coordinate and time, plus summation qi pi. Okay, now we can write it like this because the variation of f at final and variation of f at initial positions is still going to be 0, because all these quantities do not vary at the endpoints, and therefore this quantity will also not vary at the endpoint. So it is justified that we can write it like this. Okay, so if we write it like this, then if we substitute in equation 1, we will get df equal to df3 plus summation dqi pi plus summation qi dpi. This must be equal to summation pi dqi minus summation pi dqi plus h dash minus h dt. Now here this will get cancelled with this, so we have df3 equal to minus summation qi dpi minus summation pi dqi plus h dash minus h dt, from which we get the relations dou f3 by dou pi equal to minus qi, dou f3 by dou qi equal to minus pi, and h dash equal to h plus dou f3 by dou t. Okay, again by using the method which we saw in our previous lecture, we can find our canonical transformation equations from these relations by doing the mathematical jugglery. Okay, and therefore this is called type 3 generating function, which is a function of the old momenta, new coordinates and time. Okay, in the same manner, if we write f as equal to some f4, which is now a function of the old momenta, new momenta and time, and plus summation qipi minus summation qipi, then we have df equal to df4 plus summation dqi pi plus summation qi dpi minus summation dqi pi minus summation qi dpi. This should be equal to summation pi dqi minus summation qi dpi plus h dash minus h dt. Now again this will cancel with this and this will cancel with this, which gives us df4 should be equal to minus summation qi dpi plus summation qi dpi plus h dash minus h dt, which gives the following relation: dou f4 by dou pi equal to minus qi, and dou f4 by dou pi equal to qi, and h dash equal to h plus dou f4 by dou t. And here f4 we call it as type 4 generating function, which is a function of the old momenta, new momenta and time. Okay, so what we have done is that we have defined 4 types of generating functions which depend on different quantities. Okay, and from this we can see that we are able to construct our canonical transformation equations, and that is the reason why we call them as the generating functions. But interestingly, if you note f2, f3 and f4 are in fact, or can be obtained by a Legendre transform on f1. Okay, now to see this, let us first perform. So because Legendre transform of f1, which I am going to call it as f1 star, with respect to the new coordinates, is f1 star is equal to plus or minus summation dou f1 by dou qi times qi minus f1. Whether you take plus or minus depends on the convention. Both are equally valid and both correspond to the Legendre transformation. The only difference will be the transformed function will have an opposite curvature if this is a negative sign, and the same curvature if it is the positive sign. Okay, so if you don't know what Legendre transform is, please refer to the Legendre transform videos in the maths playlist. Alright, so if you observe this, dou f1 by dou qi was nothing but minus pi. So this, if I take the negative sign convention here, this becomes summation minus pi qi minus f1, which is basically f1 plus pi qi, summation pi qi. So this is equal to f1 star. But if you notice this was, so if you go to the equation for f2, our f2 was given by this relation. Now here, if I write f1 as equal to f1 star minus summation pi qi, then you see that this particular guy, which is, if you compare this equation with this equation, here if we had written just df, okay, that is, if you consider this particular function, df by dt is equal to summation pi dqi dot minus summation pi dqi dot plus h dash minus h dt, sorry, there is no dt here, then our df will be equal to summation pi dqi minus summation pi dqi plus h dash minus h dt. Okay, now clearly if we do not know what this f is, we have to assume that this function f is a function of qi, capital Qi and t, which is nothing but our type 1 generating function. Okay, and here to get the type 2 generating function, we are just substituting f as equal to f2 minus this quantity, which is nothing but the relation that we have here. So which means our f1 is the same as f because of this relation, sorry, this relation. So this relation is exactly the same thing for our f1. Okay, so therefore we can conclude that f1 and f1 star here should be the same as writing f is equal to f2 minus summation pi qi. Okay, so therefore our f1 and f2, so f2 is Legendre transform of f1 with respect to our q's. Okay, so in a similar fashion we can say that f3 is a Legendre transform of f1 with respect to, so if you see here f3, so f3 is a function of old momenta, f1 was a function of old coordinate, new coordinate and time, whereas f3 is a function of new momenta. That means we have to take Legendre transform with respect to our old coordinate, so with respect to q's, and f4 is a Legendre transform of f1 taken with respect to both q's and the new coordinates as well. Okay, so this means that therefore all are equivalent, that is, we can use any of these to construct canonical transformation equation, canonical transformations. Okay, so again note that we can define other generating functions also. So to understand this, if you consider the following example, So example, if you write f as, so if you consider degree of freedom equal to 2, then if I write f as equal to f dash, which is a function of small q1, small p2, big p1 and big p2, q2, comma time. Now see that this is not of any of the type which have been mentioned so far. This is mixed type, okay, which means it is dependent on the old coordinate and momenta as well as new coordinates and momenta, but corresponding to the different I value. So this, if I write it f as f dash of which depends on these quantities minus q1 p1 plus q2 p2, then our df will be equal to df dash minus dq1 p1 minus q1 dp1 plus dq2 p2 plus q2 dp2. This should be equal to p1 dq1 plus p2 dq2 minus p1 dq1 minus p2 dq2 plus h dash minus h dt. So here this guy will cancel with so this will not cancel, this guy will cancel with this guy, and this guy will cancel with this guy, and what will be left is that df dash will be equal to q1 dp1 minus q2 dp2 plus p1 dq1 minus p2 dq2 plus h dash minus h dt. So this implies that dou f dash by dou p1 equal to q1, dou f dash by dou p2 equal to minus q2, dou f dash by dou q1 equal to p1, dou f dash by dou q2 equal to minus p2, and h dash equal to h plus dou f dash by dou t. So again, from these relations and doing the mathematical algebra, we can again come up with the required canonical transformation equations. So therefore the four types of generating functions are not the only generating functions. We can define our own generating functions as what is required. Okay, so with that I would like to end this video. I hope that you have understood it. This is just purely mathematical, not much physics in it. So thank you for watching. See you next time. In the next video we will see some examples of where we use the generating functions to come up with the canonical transformation equations. Thank you for watching. See you next time.